So welcome back. Next video is about class full addressing. So last video we said about the information as like this. So once again, what is an IP, logical addressing, and what is IP addressing. A combo of it is a combo of 1 and 0 combination. A system should have unique IP. The IP socket is A.B.C.C.D. So it is a 32-bit length. So we said about what is static and what is being dynamic. Static normally we offered for popular servers, and IP is having scarcity. So we go with the dynamic, original versus static. These are the information what we have said. In the last content we said about the IP can be notated either in a binary form, or else we can go with the decimal notated dotted notation. Normally we prefer a decimal dotted notation because it is easy to remember. So we go with the next classful addressing. Let me try to understand why we use A, B, C and D and the 4 sockets, and what is the meaning of that. So normally IP can be classified as like this. IP can be remembered as like this. If I go with either the IP will have, if I look at this as a single box, the box will have 2 internal compartments. One, it gives the information about the network ID, and another it will give the information about host ID. So either any one of the socket, at least either any one of the socket should give the information about net ID. So normally the first socket or the first part gives the information about network number or the network ID, and the later part will give the information about the host. Okay, so there cannot be a combination as like this. It should be a net plus host. So the structure should be network plus host, and this is impossible. Host plus net, this is impossible. This is not correct. Okay, so the structure, the first structure gives the information. The first part gives the information about the network ID, and the second part will give the information about the host. Okay, so at least there should be one socket. At least there should be one socket that gives the information about network number, and the rest sockets can give the information about host. Okay, so for class A, the socket A is giving the information about network number or network ID, and the rest B, C and D will give the information about your host ID. When we consider class B, the first 2 segment as 2 socket will give the information about the network ID, and the later 2 will give the information about your host ID. And for class C, the first 3 sockets will give the information about your network ID, and the last socket will give the information about your host ID. And when we go with the class D and class E, it is for reserved, and it is for the class D is for multicasting address. Normally it has been used for ad hoc networks. When we go with class E, it is meant as reserved, and it is for your research purpose. So why we go with the class A, and what will be the numbers that is been affordable by class A, that we can able to see. So remember the tip, the IP will have 2 internal segment. The first internal segment is, it gives the information about network number, and the second internal segment will give the information about host number. Mandatory, there should be minimum 1 socket need to be given for the net ID. So for class A, the first socket has been given. The first socket has been given, not the partial socket. Not the first bit, not the second bit or third bit. A continuous of 4 bits, it is not been given. At least there should be minimum 1 socket. So A is been completely allotted for net ID, and the rest 3 is been allotted by host ID. So vice versa. So when we have this study over it, so normally class A will have the condition as like this. It starts with 0 to, so the first number starts with 0, and that means the first bit is 0, that is the MSB bit is 0, and it goes until the rest 1. I can able to go until rest 1. That means it can able to go with all zeros to this number. That means the MSB bit should be start with 0. So this is class A. So this is class A. On expanding this information in your binary decimal notation, the number will be 0 to 127. So class A will have the information 0 to 127 will comes under the category of class A. So there should be a structured norms to categorize class A, class B, class C. So we use the structured structure that if the MSB bit starts with 0, then automatically it is class A. Okay ma'am. So if the MS here you can able to see the MSB bit is 0, and here also the MSB bit is 0, and the rest 7 bits are taken as 1, so that it can have the maximum combination as 1. So the number ranges from 0 to 127. When we go with class B, the number starts with 10 and closes with 10. So this will be your number. So if you analyze back, the number goes with 1 to this number. Okay, so the MSB bit once again it starts with 10 for class B, and here also it starts with 10. So the number ranges from 128 to 191. It comes under the category of class B. So if he goes with here, we can able to find the value. If we expand this value, it will be 191. And we use the weighted method, not as the binary equivalent what we learned in our digital electronics. It is a weighted method we have been using here. Okay, so if I expand 10 until the last, it is 191. So class A, it should the MSB bit should be 0, and for class B the MSB bit should be 10, and for class C the number should be 110. So the MSB bit should be 110. So if I start with, it is 110 to 110. So this will be your number. If we expand back, the number will be is equivalent to 1. It is 190 to 2. It is 2. It is 223. Okay, it is until 223. So once again we come back reverse. So it is 223. So for class D, once again the number will start with 110. So if I go with 110 to so the number ranges from as like this. It goes with the 224 to 239. And for class C, the number is all ones. The first 4 bit will be 1, and the rest of the number, it is a 242, 255 will comes under the class E category. So class D will be used for multicasting, and class E will be used for research or higher applications. I can go for any research. So once again coming back. So when we go with the class A, so the first bit starts with 0, and the last bit can able to go until the rest last 7 ones. So the what I can able to have, so the network can able to range from 0 to 127. The network can be able to range from 0 to 127, and the host, the rest will be the host. The socket B, the socket C and the socket D will be the host. So it is 2 power 24. In the sense 24 bits are there, I can able to have the maximum combination of 2 power 24, and I will subtract 2 because the first number will be used as a network number and the last number will be used as a multicasting number. Generally for any network, the first number will be used as a network number and the last number will be utilized as a multicasting number. So I am subtracting 2, so I can able to accommodate approximately 16,777,214 host. So class A, I can able to go with many host, or I can able to have unlimited host, or I can able to say that if the host is unlimited or unnumbered or unknown, I will go with class A. So this is the speciality of class A. So I can able to have 127 networks, and for every network I can able to accommodate 16,777,214 numbers of host, and it is almost, once again I can able to say that it is unlimited, or I can able to say that it is unknown. If the network capacity is unknown, I prefer class A. So class A specialties, it is if it is go with unknown network. If I can't able to predict the number of users accessing the network, then I will go with class A. Then we go with class B. Here socket A and socket B is used for your network, and socket C and socket D is being utilized for your host. So equivalent network numbers and equivalent host. So what will be the capacity as like this? I can able to go with class B. I can able to go with, so here A and B will represent net number, net ID, and C comma D will represent host ID. Okay, so in such scenarios I can able to have 255 into 255. So why I am using 255? The capacity, that is all ones, is equivalent to 255. So it is the network structure is 255 cross a 255 combination I can able to build. So I can able to accommodate 255 into 255 networks, and for every network I can able to accommodate 255 into 255 host. So once again I can able to say that if I need a large network, at the same time the network will have to have unlimited or a large number of customers, then I prefer class B. Okay, so need to have large networks, need to have large capacity of customers, then normally we go with the class B. Then we come to class C. When we come to class C, here A comma B comma C will represent your net ID, and D will represent your host ID. That means I can able to have enormous network. But for every network I can able to accommodate only 255 members alone, because the last socket is one and only, it has 8 bits. It have 8 bits alone, and the maximum capacity is all ones. Then that is equivalent to 255. If I expand in a weighted form, it becomes 255. So I can able to have enormous capacity of network, and for every network if I can able to accommodate only 255 systems, means if the capacity of this network is understandable or limited or known, or if I go with one and only constructing only minimum number of system, then I prefer class C. Okay, so once again coming back, class A, if I go with unlimited unknown number of customers, class A. If I go with equivalent number or many number of networks with many customers, then I go with class B. When I use class C, I will have only minimum customers, then I prefer class C. So these are the categorization of class A, why I am using class A, class B, class C. Okay, so once again remembering back, it is A, it is B, C. Class A, it is using first socket as its net ID. Class B, it is using your 2 socket as your net ID, and class C, it is using the first 3 socket as the net ID. So these are the difference. So once again looking back, you can able to check back. So the combination, when we use the occupancy of your address space, class A occupies 50%. Since it is occupying from 0 to 127, it is as equivalent half. So 50% it is been occupied by class A addressing, and rest 25% is been occupied by class B, and class C it has been occupied by 12.5%, and the rest class D and class E occupies next 12%, 12.5%. So D and E will have the equivalent share. This is 6.25. So this is the occupancy rate. So class A 50%, your IP address is being occupied by class A, and class B next 25%, and the last class C, class D and class E next 25%. This is the occupancy related activity. When I use class A, I can able to have many number of customers. So this is the story behind it. So when we look back, whatever the information I have to set, so I said about the classful addressing. Then we say about what is the mask. So when we come on to the network, I need alone the net ID alone. Since this my system, I have been accessing the internet. So when my packet is deliberated or delivered to the network, my router will capture the packet, and the packet is the responsibility of the router to deliver it to the last end destination. Remember, your network layer is responsible for source to destination. So myself the source, last end server is my destination. So the network layer takes the responsibility of delivery. So the packet will be renamed with source address with its own IP of the router. So my IP address will be a private number. When it crosses my router, the IP address of my system will be changed to the public address that is being used by the router. Okay, once again spelling back, if I use my number, here is my number, and I said here, this is my number. Once again I am copying here, cancel. So my system is accessing the network, so automatically this is my IP. When it crosses my router, hope the router is having any one of the number. Let the number will be as like this. I am assuming back. Okay, so my packet will take as 111. This number will be taken by my packet as the source. So this is the source address. As we discussed in the class, we remember that my packet will be delivered to the network in the risk of the router alone, and not in risk of mine. It is being delivered to the network in risk of the router, or so only we use the word service provider. So my source address will be changed, and my source address will be retained in the database of the router. So my private address is being translated as a public address, and it takes the resemblance of the IP address of the router and goes out. Okay, so when we speak as like this, I have to extract the network number alone, and the network number, since if this number, hope this is a class B something, sorry, class A something. Suppose this 111 is the router that is been corresponding to Tirunelveli, hope so, assuming that. Then if I extract 111 from Delhi, I can able to say that it is the packet that is been coming from Tirunelveli router. Maybe it is 112, it is the router number of Kovalpatti. If the number is 112, then I extract 112, I can able to say that the packet has been coming from Kovalpatti. So how to extract this number? And this is purest digital form. You remember, we will have a mask. We will have a mask. So for class A, the mask is 255.0.0.0. Why? Since the first socket is here is 255. The first socket is 255, and for class A, the socket A is having the net ID. Okay, the socket A is having the net ID. So if I have the bitwise AND operation with the mask and my class A address, then automatically these three sockets 0.0.0 will nullify the socket B. If I put as A dot, I put a number A dot B dot C dot D, and if I have a bitwise AND operation with the 255.0.0.0, then automatically B C D, since it is 0 here, automatically B C D will change as 0, and that extracts the A alone. So it extracts the A alone, so automatically the net ID can be extracted. Once again, remember back, when my packet crosses the router, my network number is having the meaning. My private IP will be hidden back. My network number is having the meaning. So in order to extract the network number, I will have a AND operation with a mask, and that number is, we use the word as mask. So here it is 255.0.0, since I want to extract A bit alone. For class B, and I need to extract A dot B, since I put a colon A dot B, since A dot B is having the information about your net number, so automatically mask will become 255.255. so rest will be 0.0. So once again I am making this as red, so that you can able to have a identification. Since the socket A is having the net number, so I am using the first socket as 255. Since A dot B is having the net number, the first two socket is 255. Okay, so if I expand here, this 255, if I expand here, I'm putting as black, expand here, it is 81.0, completely 0. So if I expand 0, it is all 8 bit 0. When I expand next 8 0, it is all bit as 0. So when I have an AND operation with A dot B, automatically A and B will be extracted, and the rest C and D will be reduced as 0. Okay, we have the same. And when I go with the class C, so the dot is A dot B dot C. So this is having the information about your net ID. So the mask will be, so normally you can able to say it is 255.255.255, since the first three socket is saying the information about your net ID, and the last bit is saying your information about your host ID, and the host ID is temporal with respect to the number, so automatically this will be your mask. Okay, so once again the same, if I put as like this, if I expand, this will be your number, this will be your mask. So continuous 24 bits once followed with 8 bit 0. So this is your mask. So the role of the mask is to extract the network number from your IP. Since your IP address is private, your IP address will be translated as a public IP, and it resembles your or it takes the IP address of your router for the packet to move in the network. So in order to extract back the network number of your router, I will be using the mask for this purpose. So rest information. So I have said about how to extract the net ID and what is the limits of class full addressing. I hope so. The video has crossed more than 24 minutes, so we stop back and we can able to come back with the next.